So in response to temperature, it gives change in resistance. This is what is the RTD. Now I want that whatever you people know about the RTD, you share with me. Yes, please. I'm sure that some of you or all of you must be knowing what is RTD. Although I introduce, as the name suggests, from name also it is clear, it basically a temperature sensor, thermal sensor, temperature sensor. Yes, please. बताइए इसके बारे में. Am I audible to all of you?
Yes, sir.
Yes, sir.
जो आप जानते हैं आरटीडी के बारे में, you tell me. Nobody knows anything. What is the material of RTD? Which material is used for making RTD? What is the response equation for RTD? You must have studied this kind of expression somewhere. RT is equal to
R naught into 1 plus alpha.
yeah. That's what R naught 1 plus alpha delta T. This means you people have studied somewhere, right? So that's why I'm asking that whatever concepts already you are having about this sensor, you should speak about that. And if there is anything wrong, then we'll accordingly I'll make it correct, and then from there on, means beyond that, I'll try to speak. Anyway, if you are not interested in speaking about anything about the RTD, then so this is RTD, whatever I explained you. Beyond that, obviously RTD is a resistive sensor, it's a passive sensor, and it is made up of metallic material, means it is made up of conductor. Okay, I'll come to that. Then in this case, unlike you must have seen, you had already studied everything about the strain gauge. In case of strain gauge, the change in resistance is because of the change in dimension of the strain gauge element, and because of the change in resistivity due to piezoresistive effect. So over there, the change in resistance is basically because of the change in dimensions, means length and area, as well as the resistivity. In case of strain gauge, this change was function of all these three. But in RTD, this change in resistance is only function of change in resistivity, that is the material property in this case. So that's what I had written. Resistivity, material property of the conductor changes as it is subjected to the temperature change. Basically, this is the behavior of the material, that when it is subjected to the temperature change, then its resistivity changes. This is the property of the material. This is the way material creator has created to behave. So this is basically, so this property is of the conductor is exploited to measure the temperature. Okay. And because of the change in resistivity, the resistance of the RTD changes. Means resistance is dependent upon resistivity and dimensions. So if any of these three will change, accordingly your resistance will change. So in this case, in RTD, your dimension remains same, your resistivity changes. Because of that, resistance changes. So the resistivity, change in resistivity is function of temperature, and hence the resistance also is a function of temperature. Means change in resistance is also function. So this is how, basically, this is the how your RTD works. So because of the change resistance, RTD are made up of platinum, nickel, and nickel alloys. Most commonly used material is platinum. We will discuss what kind of material we can, means what kind of the material. There are many numerous conducting material, and out of these different numerous different conducting material, which will be a good candidate for making RTD, that we will discuss. Most of the metallic material has positive coefficient of resistance. What is the meaning of this? You must have, you must be aware of it. Temperature coefficient of resistance. Temperature coefficient of resistance. Yes, please. What do you mean by temperature coefficient of resistance? Acha, here what is alpha? What is alpha? What
Temperature.
is this? Temperature
What is mean?
coefficient of resistance. That's correct. So how can you define it from this formula? How can you define it?
Change in resistance per unit temperature.
Change in resistance per unit change in temperature. Correct. Means alpha from this formula is basically um, delta R upon delta T. Not exactly, although approximately this is. So what will you call it? This alpha term, what will you call it if it is defined by this formula? What will you call it? RTD, which is a thermal sensor, temperature resistive sensor. Input is T and output is response is R. What will you call ratio of change in resistance to change in temperature?
In sensitivity.
Sensitivity. Basically, alpha is sensitivity of RTD. Okay. So if alpha value is more, then we'll say that the RTD is more sensitive. And if it is less, then it will be. Now, alpha is not exactly defined as this formula, but it is formally defined as the fractional change in resistance to the change in temperature, to per unit change in temperature. This is how alpha is defined formally. Although the meaning remains same, this is also a sensitivity, and if we are not taking fractional change, that is also. So this is one of the way. And generally, you must have, means the unit of it is per degree Celsius. So it is only because of that, because at the numerator we are taking fractional change, so that is not appearing into. So this is how alpha. Anyway, that's good. So then what do you mean by positive alpha or positive temperature coefficient of resistance? The meaning is that if we are drawing R and T curve for any RTD, then what do you mean by alpha with respect to this curve?
Slope.
Slope of the curve. Correct. Good. So it will be slope. So positive slope means obviously you'll get this kind of curve. So as the temperature increases, your resistance increases. As the temperature decreases, your resistance decreases. So the direction of change in resistance and temperature will same, and it is called positive temperature coefficient. If it is different, means if it is like this, then we'll call it negative. Okay. So the positive temperature coefficient of resistance means as the temperature increases, resistance of RTD increases, whereas it decreases as the temperature decreases. That's what I told you. Temperature coefficient of it is whatever I told you here. Here it is explained over there. The temperature coefficient of resistance is defined as the fractional change in resistance per unit change in temperature. So this is all about your salient points of the RTD. If anybody is having any doubt or not able to understand any of these points that I told you about RTD, you can ask me. You can make it clear, please. Okay. Now, as I told you that there are many materials, different materials, conducting material, which can be means as far as the RTD is concerned, any conducting material, piece of the conducting wire of the conducting material or piece of the conducting material can be used as a RTD. But all of them are not good to be used as RTD. You try to understand. I'm elaborating it with respect to so this is the required attribute of the conductor material to be used as RTD, or you can say that the material which will have all these attributes, it will be more suitable to be used to make a RTD prop. Obviously, the first one is very straightforward. That temperature coefficient of resistance of material should be high as possible. Sensitivity, whatever material which we are using to measure the temperature, should be should have good sensitivity with the temperature. This is the obvious thing. We want that the material should have large value of alpha. It should have good temperature coefficient of resistance. Second thing, the resistance of the material should have continuous and stable relationship with the temperature. So I'm using two words, two adjectives: continuous and stable. Both of these two required. I'm sorry. Hello. बोलो. जी जी बोलिए ना, बोलिए. अच्छा जी बोलिए. मैम आरटीआई जो है वो आरटीआई एमआईएस पोर्टल से आती है, गवर्नमेंट ऑफ इंडिया का ये पोर्टल है. और वो हमने आपको ज़रूर इससे पहले आरटीआई जो आपने प्रोसेस की होगी उसके लिए हमने आपको वो भेजा होगा, क्या नाम है, लॉगिन पासवर्ड. लॉगिन मैम एक रिक्वेस्ट डाल दीजिए. मैम एक रिक्वेस्ट डाल दीजिए अपने ईमेल से, उस पर आ जाएगा वो. आप CPI at CJMI. ठीक है, ठीक, प्लीज. So the resistance of the material should have continuous and stable relationship. So what is the meaning of continuous? Any material, and this is these two attributes is true for any sensor. Means like in case of strain gauge, your strain gauge resistance should also have continuous and stable relationship with the strain. Means your whatever material you are choosing to make a RTD, it should have continuous, means whatever range you are choosing as far as the RT curve is concerned. So whatever range of your interest, that relationship your relationship should be continuous. It should not be like this, in between somewhere it is not responding at all, dead band. That kind of thing should not. So otherwise it will be called discontinuous. Means somewhere it is because material may behave like that. You cannot say. And there are many materials which having certain range, they behave, they vary, the resistance of the material vary in particular way, and then in between it is not varying, following same thing. You must have seen saturation, you must have studied saturation of magnetic material, that kind. So I'm not going in detail, but the requirement is that your whatever material you are choosing, it should have this kind of relationship instead of this kind of discontinuity. One thing, this is about the continuous. Second thing, it is about the stable. Stable means your characteristic of the, like you have chosen copper, you have taken the copper wire, copper probe. So today that piece of copper is having this characteristic. After some time it is having this characteristic. So it is not stable because there is a drift in the characteristic. Earlier, this much resistance was indicating this much temperature. Now, after change, after drift, it is changing. It is only this much temperature. So there is error because you will measure only this one, because you know this characteristic. You never know whether the characteristic has been drifted or not. Although there is a mechanism for doing that, but in any case, we don't like a material whose characteristic drifts. And this is not true only for the RTD, it is true for any sensor, So you can say that in general, you can say that the response of the material with respect to the parameter which stimulus or parameter which we want to measure, the sensor should have continuous and stable relationship. This is all right to all of you? G, are you able to understand this point?
Yes,
Yes,
sir.
sir.
Now the third is that's why platinum is preferred. Platinum is a very stable material. Its characteristic does not change. So it's a bit basically non inert material. It does not react with the uh, environmental parameter and other, and their melting point is also high. So that's why platinum and nickel alloys they are very stable material basically. Then third one is the material should have a high value of resistivity so that minimum amount of material used for construction. Well, this is basically miniaturization. So resistance, suppose PT, if you go to the market, then PT 100, if you want RTD, then you have to tell you need PT 100. PT 100 means this is a commercial name of a platinum RTD probe. So PT 100 means the probes at 0 degrees Celsius, the probe resistance is 100 ohm. That's why it is called PT 100. And when the temperature will vary, accordingly resistance will vary. So this is basically your. So this is from this point. The third requirement. That R depends upon depends upon resistivity as well as length and cross sectional area. So for if your resistivity is high for a given cross sectional area, you require less length to achieve 100 ohm. You understanding what I'm saying? So obviously if resistivity is high, then your probe size will be very small. So this is a kind of miniaturization. Many places you will find you require basically if you are using bigger and bigger means time lag with dynamic characteristic that is not in your course. Basically, it will take more time to absorb the heat and to rise the temperature. And if you are having a smaller piece of probe, then its response time will be less. Means it will work faster. So that's why miniaturized probes are means preferred. And many places we want very small size. Obviously, it means we don't want bulk sensors, means very large size, unless until there is some application for that. Otherwise, we generally, so all these are the attributes that we require a material should have, if we want to use that material for making a RTD prop. So if anybody is having any question regarding these three points, you can ask, please. Should I go ahead with your
Yes, sir.
permission?
Yes.
Any time, there is no time to join the class, eh? Anyway, okay. Now I'm coming to the second part that is very important: temperature resistance characteristic. As I told you earlier also, what is calibration? I'd explain this calibration with your strain gauge also. I explained earlier also that sensor basically converts the parameter which we want to measure into another suitable parameter which facilitates the accurate measurement of the stimulus. Suppose this is X and it is converted into Y, and then we measure Y. We measure Y accurately. But our objective is not to measure Y but to measure X. Then how can we measure X by measuring Y? जी बताइए भाई. कुछ तो बोलिए.
कोई फंक्शनल रिलेशन होगा उसके
जी
थ्रू. कोई
जी
फंक्शनल रिलेशन होगा उसके थ्रू.
क्या होगा?
कोई फंक्शनल रिलेशन हो वाई और एक्स के बीच.
That's correct. We need a relation between Y and X, obviously, and this is the requirement for all the sensors, for all the sensors. So the process by which we means establish the relation between the response of an instrumentation system with the stimulus is called calibration. Is called calibration. Like suppose many times you will see that you will find this kind of relation that is called polynomial relation, that that is x is equal to a naught plus a1x a1y plus a2y square, and so on. And so on. So if look upon it, if it is a linear relation, then we'll have only two terms, and if it is non-linear relation, then we'll have more than two terms. Now when will you say that the relationship is established? Means once we are able to establish this kind of relation, so if we know the y, we can find, we'll put the values, y values here, we'll get the value of x. But when will you say that this relationship is established? When will you say that? For a particular sensor, जी मैम 12 बजे, 12 बजे ठीक है, है क्या ये वेन्यू तो यही दिया हुआ है मैम।
इकबाल सर मुझे मना नहीं करते ना, तो तुम्हारे लिए खुला और किसी के लिए नहीं खुला। इकबाल
मार्केटिंग है, मार्केटिंग ये
मैं गया ऑफिस वालों को मना कर दिया, फिर मैं गया।
So this is basically we'll say this relationship has been established only when these coefficients are known. बात समझ में आ रही है कि नहीं? भाई हाँ नहीं तो कर दिया करो तुम लोग। मतलब अगर हमारे पास एक रिलेशन ऐसा है x इज इक्वल टू 0.5 प्लस y, तो हम कहेंगे एक्स वाई के बीच में रिलेशन मिल गया हमको, है?
यस सर।
इस कोफिशिएंट की वैल्यू 1 है, इस कोफिशिएंट की वैल्यू 0.5 है। अब किसी भी x की वैल्यू के लिए आप y मालूम कर सकते हैं, y वैल्यू के लिए x मालूम कर सकते हैं, है ना?
यस सर।
तो कोई हमारा जनरल इक्वेशन ऐसी है, अगर उसके कोफिशिएंट की वैल्यू मालूम करनी है तो उसके लिए आपको क्या चाहिए? What is the requirement? How will you find a0, a1, a2 and so on?
रिस्पॉन्सेज चाहिए।
आपको डेटा पॉइंट चाहिए, एक्स वाई चाहिए, है ना? डेटा पॉइंट चाहिए।
यस।
और वो डेटा पॉइंट हम एक्सपेरिमेंटल डेटा पॉइंट से लेते हैं, एक्सपेरिमेंट करते हैं सेंसर के ऊपर, स्टैंडर्ड इनपुट देते हैं, स्टैंडर्ड आउटपुट लेते हैं और उससे फिर हम इस इक्वेशन को सॉल्व करते हैं एंड देन वी फाइंड द a0, a1 and this process is called, means getting experimental data points and then calculating the coefficient value, it is called calibration. It is called calibration. अब आप कहेंगे कि हमने लैब में किया था तो हमने तो कुछ एरर निकाली थी, है ना? आपने जब भी कैलिब्रेशन का किया होगा तो उसमें क्या करते हैं हम, ये मैन्युफैक्चरर यही करता है। सबसे पहले आपका इंस्ट्रूमेंट जो कैलिब्रेट होता है वो मैन्युफैक्चरर के पास कैलिब्रेट होता है। फिर उसके बाद हम क्या करते हैं कि ये इंस्ट्रूमेंट, हम ये करते हैं कि इस इंस्ट्रूमेंट, ये एक पूरा इंस्ट्रूमेंटेशन सिस्टम, ये पूरा एक इंस्ट्रूमेंटेशन सिस्टम, इसमें एक रेस्पॉन्स देते हैं और एक किसी स्टैंडर्ड, जो आप लैब में करते हैं, एक किसी स्टैंडर्ड इक्विपमेंट में देते हैं, है ना? पोटेंशियोमीटर का एक्सपेरिमेंट किया होगा आपने, है ना? वोल्टमीटर कैलिब्रेट करते हैं पोटेंशियोमीटर से, तो हम वही वोल्टेज जो है वोल्टमीटर से मेजर करते हैं, वही पोटेंशियोमीटर से करते हैं। अगर दोनों में डिफरेंस है तो हम कहते हैं कि ये इंस्ट्रूमेंट जो है वो सही नहीं है, कैलिब्रेशन सही नहीं है। तो ये जैसे आपने इसी पैरामीटर को आपने इस इंस्ट्रूमेंटेशन सिस्टम से मांगा और नापा, और इसी को आपने एक स्टैंडर्ड इक्विपमेंट से नापा। इफ देर इज a difference between these two, then we will say that these coefficient means characteristic drift हो गया है, there is a characteristic drift, okay, and your instrument requires recalibration, ये coefficient फिर से calculate किए जाएंगे, है ना? That kind of thing. Anyway, this you just remember what is the calibration. Calibration is basically the process by which the response, and all of them are not linear, I mean, they are not a straight line, all of them are non-linear, and this is the graphical representation and this is the mathematical representation of these curves. So obviously these non-linear curves can be represented by a general polynomial. Here it is a polynomial, alpha 1 delta t, alpha 2 delta t square, alpha 3. It's a polynomial of delta t. Whatever expression that you are aware of, it is the approximation. It is the approximation. Or you can say that straight line approximation, linear approximation of the actual characteristic. So this is R naught 1 plus alpha delta t. That is, it is we are taking only first two terms and we are neglecting other two terms, the higher order terms. So this is what is calibration, and then the RT curve of the RTD, and how can we represent it mathematically. All these things I discuss. At this point, I'm stopping today. I'm having some departmental engagement today. So I'm stopping my lecture here, and you try to go through the whatever I've discussed and go through the calibration. So I'll finish this. This is a very important topic from concept point of view. Because whatever calibration which I'm trying to make you understand, it is valid for any instrumentation system, whether RTT based or strain gauge based or any other sensor based. So you try to understand it, and if you're not able to understand, you let me know. This is a very important concept. Okay, so I'm stopping it today's lecture here, and we'll start from here on the tomorrow in the first period. So I want that you should go through it. And another thing which I want to tell you, that I won't give you home assignment. Time to time I'll give you quizzes, and the quizzes marks will be evaluated as assignment marks. Okay, so you try to be sincere about your quizzes, because as I had seen, whatever quiz that I gave you on the last turn, only less than half of the student are able to complete it. So try to be sincere whenever I'm giving you the quiz later on. You all of you should respond, and otherwise you will miss your assignment marks. So now respond your roll call, and